is Maxime, and for those who don't know me, I've been working for PTC for quite a long time now. I used to be HR first, and then I became a business analyst in the IT department of the group, which basically means that I'm definitely not working in the energy or climate sector. I'm not an expert. But I've been interested in these topics for 2 to 3 years now. I've been reading a lot of books and articles and watching videos and tutorials and stuff. And I started to realize that people around me, like friends, family, and colleagues, etc., they were all quite interested in climate change, quite obviously, because it's a big topic. But most of the time, they didn't know much, except from what's in the media. And I realized that I wanted to share my knowledge, and that's how I got this idea of building this presentation, which was already given in French 1 month ago for PTC. And so that's why I coordinated with Milad, and we joined together today to talk about this topic. So before starting, I want to remind you a few things. First of all, sorry for my English. I'm not a native speaker. I do hope that I'm not going to be looking for my words too much. Definitely hope so. Also, since I'm French and most of my research and my sources are from France, so I will be giving some examples based on France. So sorry for that. And finally, feel free to participate. You may use the chat, but you may also just interrupt me if you have questions, or if there's something you did not understand, or even if you believe there's a mistake in something I said. I really encourage you to do it. So let's start today with energy and climate. It's a big topic, and this presentation really aims at giving you the basics to understand what's at stake when we hear about climate or even energy. In order to really be able to have a critical opinion about things, because we hear a lot about this in the media, and this is the kind of words that we hear almost every day, like renewable energy. Since a few months, we've been hearing a lot about hydrogen. You might have heard this a lot. Of course, greenhouse gas, fossil fuels, etc. And most of the time, the way we hear about those in the media or even in advertising by companies, etc., it's not well said. It's usually very simple. It's usually black or white. It's usually with bad intent behind, usually commercial intent behind or political intent. And most of the time, we miss the relevant information behind those terms. So the purpose of this presentation is really to give you a way to have the basics to build a critical mind about all this. So today we're going to be discovering two main parts. First one is going to be about climate change, and the second one is going to be about energy. And you will see, of course, why energy is so much linked to climate change. And finally, we will have a small part at the end regarding what we can do at our own level. And hopefully we will be giving some quiz throughout the presentation to make it a bit more interactive and hopefully to make you test your current knowledge about this topic. So I'm going to start again. Feel free to interrupt at any time. So climate change. Um, you have certainly heard about IPCC, which is in French is GIEC, which is the Intergovernmental Panel of Experts on Climate Change. So this is an international group of scientists. It's actually a meta-analysis based on more than 800 scientists, 80 countries, 30,000 contributions. So it's really a huge meta-analysis, which makes it very confident in terms of what we can expect from the conclusion. And they reached 4 conclusions in their report of 2014, which was the report on which the Paris Accord of COP21 was based. 4 conclusions, which are that the first one is that the human influence on the climate system is clear and it's not debatable. And the recent emissions of human activities of greenhouse gases are the highest in history, and they have an impact on the climate. And this is the second conclusion, is that the continued emission of those greenhouse gases will cause further warming and long-lasting changes on the climate. So they have already started to have a warming effect. And they will increase the likelihood of severe and pervasive and irreversible impacts on people and ecosystems. So we have to tackle those impacts and those changes. And the third conclusion of the report is how to tackle this. And basically, they talk about 2 strategies, which are adaptation and mitigation. So adaptation is of course, how to adapt to the changes that will occur. And mitigation is how to reduce the risk. And for mitigation, there is almost only one thing to do, is to reduce the emissions drastically. And finally, the fourth conclusion is that we cannot do only a bit of this and a bit of that. We have to do it, all of them, on a large scale at the same time and in an integrated manner, through policies and of course through social objectives as well, in order for this to be really relevant. So they have demonstrated that the cause and the effect is the global warming, obviously, and you can see on those graphs that comes from the report as well, that of course the temperature on of the ocean surface has increased drastically since the Industrial Revolution, and especially since the 50s. Of course, the sea level as well. And you can see on the D graph that the CO2 emissions have had a real drastic increase since the 50s. Most of them due to the combustion of fossil fuels, and a little bit of them due to the use of forestry, and especially deforestry. So those emissions, which are anthropogenic, so which really results from the human activities, have a direct effect, which is the C graph, which is the increase of their concentration in the atmosphere. This is very logical, right? You put more greenhouse gas in the atmosphere, so their concentration increases. So the C graph is showing this concentration. The unit is parts per million, and they detail the 3 main greenhouse gas. The green one is the CO2, which is the main one, because you will see on the next slide that it's the main one. Then you have the orange one, which is methane, and finally the red one, which is nitrous oxide, and in French this would be oxyde d'azote or protoxyde d'azote. So those are the 3 main greenhouse gas, and their concentration increases, and that's the problem. This concentration is causing the effect on the climate, and this has been demonstrated. So the cause, of course, are this greenhouse emissions, and you can see here in yellow that the main part is the CO2. It's 65%. It's not the worst in terms of effect, of greenhouse effect, but it's the worst in terms of lifetime, and also in terms of quantity, because it's what we put the most in the atmosphere. And in the report, the data was ending in 2010. So I went to the International Energy Agency, and I just took some data to continue the curve, and you can see that after 2010, of course, it kept rising. I'm talking about the CO2 emission. They kept rising. And even though they were a small decrease during the COVID, it kept rising as soon as from December, when the China economy went back on track. So it's definitely rising even today, even after the COP21. So one of the most important part of the work of the IPCC, the GIEC, is this one. It's what are the different scenarios that we can imagine when we have understood the cause of the problem. And you can see on the A chart that they have identified 4 scenarios, which are actually 4 group of scenarios, because they have studied a lot of different scenarios, and they have combined them into 4 main scenarios. They are called RCP, representative concentration profiles. And the dark blue one, the 2.6, is the one that we want to achieve with the Paris Accord. It's this scenario that will keep us below the 2 degrees at the end of the century. This scenario implies that we are going to reduce our emissions up to 70% starting now, before 2050. This scenario means that we are going to keep the temperature below 2 degrees. It's what you can see on the right picture. The concentration has to be kept under 450. So here it's written between 430 and 480, but the target is 450. And this means that we might keep the warming under 2 degrees. So this is the scenario that the IPCC expects, and that the country engaged into when they signed the Paris Accord. But there are other scenarios. The red one, the worst, is the one in which we do nothing. And of course, in this scenario, it's going to be a catastrophic event, because the more the concentrations, the more the temperature difference. So this is represented in the right chart. And to understand the impact of the temperature, we have a first question for you that will be provided by Milad very soon, and that should be displayed on the screen on the presentation. So it's a quiz with some answers, and you might just tick the answer and reply in live. Do you see it? I'm going to take a look at the chat as well.
Not yet.
Yeah, in the chat, yes.
Yeah, you will see it in the chat as well, of course. In the chat, you will also have the results. So when you see it, you can then reply, or if you don't see it, you can go to the chat and you will see it, and you can reply on the chat. It's a poll done with forms. So the question is, how colder was last ice age as compared with today? So last ice age was approximately, I don't have the numbers in mind, but I think it's something like 20,000 years ago or 25,000 years ago. Just to give you perspective, at this time, the sea between France and England, it didn't exist. It was land, and it was ice. And the ice went until up to the middle of France, approximately. So what was the temperature difference between this time, when the ice was up to middle of France, and today? So I will let you answer. I think most of you have answered already. I have the majority of answers that are saying it was 10 or 13 less than today. Actually, only 2 people get it right. It was 5 degrees. The real answer is 5 degrees. So the last ice age was 5 degrees below the current temperature. So it makes you realize how much the temperature difference has huge impact on the ecosystem and on the climate. And this is one of the of course of the results of the report of IPCC. It's what are the consequences of this global warming. So the first one obviously is the consequence on ecosystem, on the warming, etc. And the landscape that will be modified, but also the aggravation of extreme phenomenon, which definitely we talk about tornadoes, fires, obviously, etc. And the combination of those two will obviously have social economical impacts. And the more the temperature difference, the more those impacts and those risks. And so the whole idea is to maintain the risk at the minimum level, and that is why the scenario is to keep below 2 degrees, because above 2 degrees the risk will be absolutely high, and it might be very complicated to deal with those. So let's do a focus on Europe. What will happen with Europe? This is the next slide. So when we talk about Europe, the main risk is going to be in the coastal floods due to the sea level that is rising. And this might sound like nothing, but it's actually very important because a lot of our strategic infrastructure are along the coast. Of course, the harbors like Antwerpen, of course, or in the Netherlands, there are a lot of harbors from which we import all the goods we consume and we use every day. But also the power plants. The majority of power plants are on the coast because they use the seawater as a cooler. So the floods on the coastal are going to be a critical risk for Europe. Also, water restriction, especially in the south, and increased heat events and wildfires. So you have certainly noticed that the three last summers, especially 2018 and 2019, were very hot. And you might remember 2018, where the grass was completely dry all over Europe. And Sweden had the worst agriculture results they had in their history in the year 2018. And when we take a look at the numbers, they concluded that the added value of the agriculture sector in Sweden lost 88% in 2018. The agriculture results, the agriculture added value. So if it's only one country and only 1 year, it's okay. They can count on their neighbors to provide food for everybody. But let's imagine that this will happen every year in all the countries. It starts being real complicated to deal with those loss, especially when we talk about food. So the warming is real, and it's going to cause serious effects on the whole world, and Europe will not be épargné. I don't know how to say. Let me check. Saved. Europe will not be saved from those impacts. So in order to tackle this challenge, the report has issued a lot of different strategies, which are separated into adaptation and mitigation, as I said at the beginning. Regarding the adaptation strategies, they give a lot of examples that I've put here in the report. Engineered strategies, for example, seawalls and coastal protection structure, adapting power plants and electricity grid adjustments in order to be able to manage those floods. Also, technological option like isolating buildings, obviously, or inventing new varieties of cereals that will better manage the heat events. Also, economic options, financial incentives, which are really important. We talk a lot about the price of CO2. This is a typical financial incentive that may have a real impact on companies, but also education options, like to really raise awareness directly on the children at school. So those are adaptation strategies. They are really important to be tackled by countries already. And we have seen with, unfortunately, with COVID, that countries were not ready to use some adaptation strategies to better be resilient to those changes. So this will be a real challenge for countries. The second strategies are mitigation. So basically how to reduce emissions of greenhouse gases. And here you don't have many options. Actually, you have 4 options. First is reduce the use of energy. This is called sobriety, I believe, or also energy efficiency. It's how can we do what we do by using less energy, and so by polluting less, and especially in terms of greenhouse gases. The second one is decarbonizing energy supply. This is really important. We need energy for our everyday life, but this energy is carbonized, and one of the challenges is to decarbonize it in order to have a low carbon energy and to reduce the emissions with having the same amount of energy. This will be managed in the next part. You can also reduce the greenhouse gas intensity of end user sectors. The good example is by isolating buildings. It means that for the same results, you use less you have a less greenhouse gas intensity on the building sector. And finally, to enhance carbon sinks. And there are not many sinks. You have the forest and you have the ocean. And enhance carbon sinks, we can only act on the forest. So basically planting trees and stop deforesting, of course. This is how we can enhance the carbon sinks. We can also capture and store carbon. Some technologies exist. It's not significant. So it's something that is used in the scenarios by the IPCC. It's very often mentioned in the scenarios. But today, at the industrial level, it's really not significant. It's only 1,000,000th, no, 1,000th of the carbon we put in the atmosphere. So it's really nothing today, but it's something we can work on, which is called carbon capture and storage. So the important thing is that the report says that if we don't substantially decrease the emissions before 2030, this will substantially increase the challenges associated with limiting the heating to 2 degrees. And the problem is that 2030, it's tomorrow, right? It's been 6 years since the Paris Accord, and basically nothing happened. So 2030 is in 9 years. So it's really tomorrow, really tomorrow. So we have to be conscious that the decrease of the emissions have to start now, really now, in order to avoid the worst. So I wanted to, I was curious about what happened after 2015, after the Paris Accord. So I took the evolution since then. And as you can see, obviously the CO2 emissions have increased. And the main of the growth is due to Asia, China, and India, because the rest of the world is decreasing actually. So you might think that this part of the world, Asia, China, and India, are responsible for it. But it would be a bit wrong, because we have especially in Europe, we have delocalized our production, and most of what we use and consume every day are produced in Asia. So obviously, the growth of the emissions that are due to Asia are actually due to our own consumptions for some part. So it's definitely something that the rich countries are also responsible of. I also wanted to show you this graph. I will not go into it in details because it's huge, but you might go back to the presentation afterwards and take a look for yourself. It gives you the greenhouse gas emissions by sector. It's quite interesting. And obviously, what you can see here is the reason why the second part is going to be about energy. It's because it's basically the majority of the problem is the consumption of energy. So that's why the second part is about energy, which is the ground of our civilization, which is what we use every day, of course. So far, do you have any question? Do I go too quick or anything? Just let me know. Otherwise, we can move. You can interrupt. I will start with the energy. So, what is energy? The thing is that energy is it's just a physical value that is responsible for a change. So, whenever there's a change in a system, it means there is energy involved. For example, from cold to hot, from motionless to in motion, from electricity, we talk about turned off, turned on. This is a change, so there is energy. And in everything we do, sorry, involves changes. So it involves energy. For example, moving a car, heating water, heating a room, etc. This is quite obvious. But when we talk about energy, we often hear some terms, a lot of different terms. So I wanted to remind some of them here, so that you don't get lost if you hear those. Primary energy is what is directly available in the environment. Somehow it's almost what you could grab. Of course, you have wood, you have coal, you have oil, gas. You also have the solar rays. You cannot really grab them, but you can feel them on your skin, especially in the recent days. This is a real primary energy. You have also the wind, the water, etc. Then you have secondary energy, which results from the transformation of the primary one, especially with some primary energy that makes actually no sense. For example, oil or gas. There's really nothing you can do with oil except burning it. And by the way, we didn't discover oil in the 80s. I mean, in the 18th century, we discovered oil in the antiquity. So um, the real energy that we can get from oil is when we burn it and when we put it into a steam engine. And this is the secondary energy, is the energy that is actually the result of a transformation. So you have heat, you have electricity, you could have kinetic energy, is what you get when you have the wind going through a windmill, etc. We sometimes also hear about final energy, especially when we take a look at the energy on the country level. This is the energy that is consumed by people. And I will say it later, but don't forget that energy is not only electricity. So when we talk about the final energy that is consumed by a country like Belgium, it's not only electricity, it's also the rest of the energy, like oil for the cars, like gas for heating the buildings, etc. Then we can hear about potential energy, is the energy that is contained in a certain form, but it has not yet been released, like a liter of oil or a water in a water dam. This is potential energy. And usable energy is the energy that is delivered after you have transformed it, and then you can actually use it. For example, electricity is usable energy. So those terms are important to know. It gives you a good idea of what we talk about. You have some units here. Most of the time we talk about kilowatt per hour. Also, one TOE, which is ton of oil equivalent. In French, it would be tonne équivalent pétrole. This is very often used because it's a big amount of energy, and when we talk about activity sector or countries, we usually use this one. And to give you an idea of what's the final energy that is consumed per year per person, the average in the world is 1.9. But it's not spread in equivalent manner. As you can see, an average American has a huge consumption of almost 7 ton of oil equivalent. France is 3.9, and of course people from Senegal it's zero point 0.3. So you can see that it's mostly rich countries that are responsible for this the majority of the emissions. So wait, I have trouble with moving the slide. So in order to give you a good example of how we depend on energy, I like this example of the cotton T-shirt, because every morning we can put on a T-shirt, and I like the fact that this is a real simple example because it's 100% cotton. So it seems very simple, but when you take a look at what's involved, you can see that how much we depend on energy. So, whoa, too quick. So first you need cotton, so you need sun and water. Then you need machines to manage the fields, and of course those run on oil. You also need fertilizers if you need to do it on a big scale. And the big majority of agriculture use fertilizers. And fertilizers are a big emitter of nitrogen, which is protoxide d'azote, and hydrogen as well. So in order to produce this fertilizer, you need hydrogen, and the majority of the hydrogen and the nitrogen is made out of coal and gas today. The majority. Then you need to weave and you need to dye to color the produce. And for this, the majority of the plants that are used are electricity-based carbon, coal and gas plants. So the electricity is generated with coal and gas. And for the colors, you need a little bit of chemicals. Then finally, for the transport, the majority is, of course, by sea, and this is running on oil. Then the road transportation is also running on oil. Finally, when it reaches our stores in our countries, the electricity and the cement that is used to build the store is almost always based on gas or coal. And when you go to the store with your car, you also run on oil, except for the electric cars, but they are very little as compared to the others. And also the electric batteries and the cars are made with coal electricity made in China. So again, it's coal. And don't forget that the T-shirt was designed in an office, certainly in Europe. The office and the building was made out of cement, which is a big, and cement and steel, which is of course coal. And then you have electricity, usually gas or renewables or nuclear, and yeah. So this gives you an idea of the whole chain behind one very simple thing like a T-shirt. And it gives you also an idea when we talk about renewables, especially in Europe. Okay, we have renewables for electrifying a building, but it's 10% of the chain of the problem. So if we need really to tackle the challenge, we need to tackle the value chain that is behind all the products we consume every day. So it's really an important thing to keep in mind, is for any product, the value chain that is behind is almost 100% based on fossil fuels, almost 100% today, even if the Paris Accord was 6 years ago. And this is really important to keep in mind. So another example of this, and this will be the next quiz, is this next slide. I will let you put the question, Milad. So the question is now available in the chat, and it should also arrive in front of the presentation. I will read it out loud, but you can start, of course, replying. How much kilo of resources do we need to build a laptop? A laptop with an average of 2 kilos. How much kilos of resources do we need to build it? I can see people are replying. I start to have a majority here. Okay, so the majority have replied 250, some of you also 480, and 4 people replied 800, and it's actually 800 that is the correct answer. And you can see it here. Actually, in order to build a 2 kilogram laptop, first of all, you need 200 kilo of fossil fuels. Then you need 600 kilos of raw materials, among them ores, which in French would be minerais, and metals, of course. Not only rare metals, we often hear about rare metals, but just simple metals, aluminium and steel. It's really important, and it represents a big weight. And so this represents 800 kilos of resource, not mentioning the millions of liters of water that are used in the process and usually a source of pollution. So again, it might sound simple, it might sound obvious, but we hear a lot about dematerializing through digital, especially in the tech world. And we talk about the cloud and the digital, that everything is going to be cleaner or greener. But of course, definitely not. You know that a server is a laptop. It's not a laptop. A server is a computer, and a computer is fossil fuels and raw materials. And the cloud is a group of server. So there is nothing green, there is nothing clean, and this gives you a good idea of what's behind it. So I like to take the example of the Kaya equation to understand what we can do about this. So Kaya is a Japanese engineer that has come up with a very simple equation that gives you a good understanding of things. Let's take the total world emissions. So this represented by this CO2 here, which are equals to itself. Of course, this is valid. Then he adds the total, sorry, then he adds the total energy production of the world energy production. So here, you can see that mathematically speaking, it's perfectly valid. Then he adds up the world production, the economic production. And sorry, by the way, PIB is a French acronym. I should have translated to GDP. I forgot about this, sorry. So this would be GDP. And then you can add the world population. So he just added those factors in order to isolate some factors here. The first one would be called carbon intensity. It means for one unit of energy that I produce, how much CO2 do I put in the atmosphere? This is called the carbon intensity of the energy. Then the second factor that is here is the energy efficiency. For 1 unit of economic production, how much energy do I need? This is called energy efficiency. And finally, of course, for one person, how much part of the GDP he gets. So this is the GDP per person. And the last one is the population. So why doing so? Why this equation? It's just to make you realize that if you want to reduce the total number of greenhouse gas, the first one, the CO2, you need to reduce one or several of those factors. Obviously, you don't want to reduce the population. This means wars, etc. We don't want this. You don't want to reduce the GDP per person because it means increasing poverty. So again, we don't want this. So basically, we are stuck with those two factors here. We must enhance the energy efficiency, and we must work on the carbon intensity. So energy efficiency, it's really nice. The engineers have made a lot of progress, and our cars are better. Our refrigerators, they consume less and less, etc. But we have to be careful. There is something called rebound effect. In French, it's effet rebond. It means that it's not because something is more efficient, that it will release less CO2. The good example is the cars. The cars have been more and more efficient after all the years. But a car from the beginning of the century was something like 500 kilos. And a car today is 1 ton and 0.5, something like this, especially if you talk about, um, um, I don't know how to say, these big cars that people use every day. So the weight of the car has increased. Of course, the efficiency has increased, but the weight as well. Yeah, SUV. Thank you, Benjamin. So in total, the energy and especially the greenhouse gas emission has increased, even though the efficiency has increased. So we need to be careful about efficiency. And carbon intensity is the energy source that are decarbonized. And this is really important to really work on this first factor here, is how to decarbonize the energy that we use. This is really important. Something that is missing here, and it's a pity, is the concept of sobriety. Obviously, one of the first thing to do, and it's part of the conclusion of the IPCC, is that we need to consume less and less energy and less and less and produce less goods, etc. If we want to achieve the target. So let's focus on the carbon intensity. This is the world CO2 emissions per energy source. So it's quite straightforward. You have coal, which is the worst. Then you have oil, then you have gas, and then you have nothing. So basically, it goes without saying that the problem is fossil fuels. That's it. Especially coals and then oil and then gas, but the three of them are really, really a problem in terms of emissions of CO2. Now let's take a look at electricity. Because the great thing about electricity is that it can be decarbonized. And that's really something very important that we must work on as populations, countries, etc. Today, the different ways to do electricity are coal, gas, biomass, or also, of course, renewables like solar, hydro, windmills, etc. Of course, we also have nuclear energy. And here on this graph, you can see how much CO2 do we put in the atmosphere for 1 kilowatt per hour of electricity we produce based on the different sources. Again, coal is the worst. Then you have gas. It's better than coal, obviously, but it's still a lot, and it's not what we want to do. We want to reduce emissions. Okay, so we need and we want to achieve neutrality in 2050. So we need to stop fossil fuels absolutely, and gas is not a solution, even though Europe tends to think that it's a solution. Then you have the renewables, and this is really good. You can see that solar panels are quite well. um, Hydroelectricity is very good, and the windmills, and especially offshore wind, is really nice in terms of low carbon energy. Also, you have nuclear energy. I don't know if you knew, but nuclear energy is really a low carbon way of producing electricity. So this leaves you with three categories, and what we want, if we want to follow and to limit the heating to 2 degrees, is to get rid of those and to replace by those. And something very important to also have in mind, I don't know if you remember, but I told you electricity is not everything. The final energy is also the one we use for cars, like oil, or the one we use for heating buildings. So the scenarios implies that we need to electrify some of those sectors. For example, the heating of buildings. If we could stop heating them using gas and replace them with I don't know how to say in English, probably heating pumps or pompe à chaleur in French. Basically electricity. And if this electricity is decarbonized, then we could solve the heating production. We can also use the electricity to build green to do green hydrogen, and this hydrogen could be used for the transportation, like the trucks or the boats. So what we must know here is that the electricity production will increase, but it has to be decarbonized. And when we take a look at the current electricity mix, we can see that it's not decarbonized at all. The majority of the electricity is made out of coal, especially in China, and also natural gas. And this is the 2/3 of the world electricity so far. Hydro is just behind, and then nuclear. But you can see that 2/3 of the electricity is not decarbonized. And this is definitely not good. We need to absolutely focus on decarbonizing this electricity, because thanks to the electricity, we are going to be able to build electric cars, to build batteries, and to build and to heat buildings, and to finally reach the carbon neutrality. So this is really important to have in mind. This is the current state of the electricity. It's not looking good, and the countries have to do better to decarbonize the electricity, especially if they want to tackle the other energy sources like oil and gas. Let's take a look at the electricity in Europe. So I have found this little video here that will show you the carbon intensity of the electricity in Europe for 1 year. It's quite simple to understand. In green, you have the low carbon electricity, and in in brown, you have the high carbon electricity. As you can see, Sweden, Norwegian, and France and Iceland are doing quite good, especially Norwegian, because they have almost 90% of their electricity that is hydro-based, because they have a lot of mountains and rivers. In France, it's thanks to the nuclear power plants that is more than 70% of the electricity. And then you have, of course, Poland, which is almost only on coal electricity plants. So this is definitely not good. It's high carbon intensity. And all other countries, they have big variations, especially Germany, because you might know that in 2011 they decided to get rid of nuclear and to replace by renewables energy. It's very good that they implemented renewable energy, but the problem of renewable energy, wind and solar, is that it doesn't work when there is no wind or no light. And this is why you need to have backup power when you need electricity, when there is no wind. So that's why the colors are changing a lot for Germany. When there is no wind, they have to activate the coal and gas power plants to build electricity to fill the gap. Belgium has recently decided also to quit nuclear, so there will be the same effect as Germany. They will have to use more gas to fill in the gaps when the renewables are not working. So with regard to the urgency of the climate, you might believe that this is not so relevant, but the policies and the different countries have chosen things sometimes for just political reasons, and it's important to keep this in mind. That in the end, the carbon intensity of the electricity will increase, which is not good when we talk about the climate urgency. So next to this, we have another quiz, another question. Which is, there are 4 sentences, and you need to pick which one is correct. First one is electricity can be easily stored. Second one is hydrogen is a green energy. Third one is it possible for a company to become carbon neutral? And finally, it is possible to maintain electricity grid stability only with intermittent electricity solution and storage solution. I will let you answer. Okay, almost over. Great. So I have to be honest with you, I've been a little bit tricky with this one. And some of you replied the third, and some of you replied the fourth. It's actually more complicated, and let's focus on the third. It's possible for a company to become carbon neutral, but the UN don't want to use this term, and they want to how can I say, they want to prevent companies from using this term, because actually it doesn't make sense for a company to be carbon neutral, especially because they do it by buying some carbon on the carbon market to compensate from the carbon that they actually put in the atmosphere. So it's definitely not something we want for a company to say that they are carbon neutral, because it's too close to greenwashing, and it doesn't make sense. So instead, the UN wants the company to use the following sentence. They want the companies to say that they contribute to the world neutrality. It's a bit different, but it's actually more relevant and less confusing. So yeah, that's for the third one, which was not correct. And then the fourth one is it possible to maintain a grid stability only with intermittent sources and storage solution? The answer is yes, it is possible. And it was recently proved by a report that was issued by the International Energy Agency and the RTE, which is the grid manager in France. And they reached the conclusion that it's possible to do it, but the storage solution do not exist yet on industrial scale. And the technology to make sure that the grid will remain stable does not exist on an industrial scale. So it would mean substantial costs, because those does not exist on an industrial scale. And it would also mean a lot of time to develop it. So it's possible in theory, on paper, but it doesn't exist on an industrial scale. So I wanted to do this to introduce some things that I believe are good to know, especially regarding electricity, because it tends to a lot of confusion when we don't know those. For example, first thing is that we cannot store electricity directly. It's not possible. And I recently attended a webinar from the R&D director of EDF, which is the electricity manager of France. And he said that, of course, it's not possible to store electricity in a direct way, but even in an indirect way, the solutions are not yet available. And the batteries are good, but only for a small scale. On a country scale, it's not working. Hydrogen could be a solution, but it would be it would cost a lot, and it would make hydrogen not competitive. So yeah, this is an important thing to know. Then the second is that electricity grids are very complex. Actually, he said that at any time, the offer needs to be equal to the demand. So if you want, if you put electricity on the network, on the grid, you need to take electricity from the grid. So I'll let you imagine how it is to manage a grid on a country scale with the whole population that can take electricity whenever they want. It's very complex, and it's already very good that they can manage this, and they can do it because they have baseline sources like nuclear or gas or coal, which they can activate all the time, and they can vary depending on the demand. So that's how they can manage such grids today. But with intermittent sources like wind and solar, you cannot have this stability because sometimes there is no wind, and during the night there is no sun. So if you want the population to be able to take electricity when they want, you need something else. So that's why I said that those sources cannot ensure the stability, all other things being equal. It means that if we want it to be the only sources, we need storage solution, and they do not exist on a industrial scale yet. That's why intermittent needs to be backed up with something that is working all the time, like fossil, like gas or coal, or nuclear, which is also working all the time. Also remind you that electricity is not the final energy. I said it already, but I can give you some numbers. For example, for Belgium and France, electricity is 20% of the final energy that is consumed. The rest is oil for the transport and gas for heating buildings and some other stuff. So electricity is not the only final energy. And finally, once the electricity is decarbonized, don't forget that the production must increase to replace oil and gas in heating and transportation. So the electricity production needs to increase. So not only we need to decarbonize, but we need to produce a lot of those. So we hear a lot about debates like nuclear vs renewables. We hear a lot, especially in France. It's a nightmare. But actually, we will need both definitely on a worldwide scale to tackle the challenge that the electricity production must absolutely increase and must be decarbonized. We definitely will need both sources to make it work. And finally, it's obvious, but it's important. There is no green energy or clean energy. Obviously, nuclear is not clean at all because you have radioactive waste. But solar panel and windmills are not green at all because you need to extract raw materials from the ground. You need metals. You need stones, and usually these are done in poor conditions, especially in China, and it's definitely not clean at all. So it's important to keep this in mind. Nothing is green, but some things are important depending on what we want to do with them. So this was for the energy part. I hope it was useful for you guys. Do you have any questions? Or so far so good? Is it still clear? Great. I see some thumbs up, so I believe it's okay. So I wanted to finish with what we can do at our own scale, because when we hear about this, we sometimes we want to some of you can feel, I don't know, depressed or whatever. Sometimes we just want to do something or to know more. So I would say that the first thing is to get informed, as you did today. By the way, congratulations. Um, really getting informed is the if you have to do one thing, is this one, is getting informed. I personally use the International Energy Agency website because it's a reference worldwide. They very recently issued a report that is great. I didn't read it yet. It's hundreds of pages, but it's amazing. Of course, the IPCC. In France, you have ADEME. For the French speakers, I really recommend those two guys, Le Réveilleur and Jean-Marc Jancovici. They are perfect in vulgarizing, or I don't know how to say, vulgariser, making things easy to understand regarding energy topics. I also recommend La Fresque du Climat. I'm personally a member of this. It's a real nice workshop to make you understand the topic with a joyful activities. It's really nice. And Fresque du Numérique is the same thing, but with the carbon impact of the digital and numerical stuff. Also some books. L'Or Noir is great. It's an amazing book about the history of oil and petrol. It's really amazing. You might also want to look at the Shift project for French speaking people. This is a think tank that wants to imagine how could be French economy if it was carbon neutral, and it's really, really nice. So to finish, just a reminder of the agenda. Don't forget the COP26 in Glasgow at the end of the year, even though we know that it's not usually very useful. But especially the next report of IPCC, it's one every 7 years, so it's really a big thing. It will be next year. Don't forget that 2030, it's tomorrow, and it's the point after which, if we did not reduce, it's over for the 2 degrees objective. Let's finish with one very small quiz. It's about the carbon footprint. So there's something you can do. Of course, it's measuring your carbon footprint. I will give you some website. But just before, I just want to ask you, and the question will appear very shortly. Yes, great. So what do you think is the average carbon footprint of a French citizen vs the target that we need to reach in 2050? So the first number is the current carbon footprint average of a French citizen. And the second is the target that we need to reach in 2050. I think that some of you started to understand that usually the worst is the is the correct answer. It's actually indeed it's the last one. It's 11 tons. It's the current French average, and the objective is 2 tons. So as you can see, there's a lot of work before reaching this objective. And there's something very nice that you can do is to start measuring your footprint. I will give you the website in this slide, which I will display here. And we will have another question for you, a last question, a last quiz. Because now that you see that if you're French citizen, your current average footprint is around the 10.8, and the objective is to reach 2. Now that you know this, let's take a look at the next quiz, and you will see how complicated it's going to be to reach this 2 tons target. I will. Yes. So this is the question. Among those activities, which one is below 2 tons? So the activities are one flight return to Paris, from Paris to New York. The other one is using a normal car 30 minutes every day for 1 year. So for example, when you go to office, it's 30 minutes. Or having one red meat meal per day for 1 year. What do you think is below 2 tons? And again, I can see that you have understood that it's always the worst question, worst answer that is correct. It's indeed none of them. No, of course, yeah, none of them. Sorry, they are all above 2 tons. So when you take a flight return to Paris, it's going to be more than 2 tons. When you take your car every day, when you eat red meat every day, so you can see that 2 tons is really challenging target to acquire. And it can give you some idea about what you can do for yourself, but really keep in mind that what we do at our own scale is very little. We cannot do much. It's basically the policies and governments that will actually have an impact. So that's something to keep in mind. We can do what we want. The idea is not to make people feel guilty about this, of course. But if you want to know more, you can use this link that I've put here. It's again, sorry, but it's for French speakers, and it will give you a good idea of your own carbon footprint and what you can do if you want to reduce it. Okay, so that was the end of my presentation. I hope it was insightful for you. I hope you've learned things and that you understood everything. If you have questions, feel free. I'm available. And of course, the presentation will be given afterwards and the recording as well. And otherwise, of course, for those who must leave, I will I wish you a very nice evening. And again, thank you for participating even late when the bars and restaurants have reopened.
So thank you very much, Maxime, again for this presentation. Thank you everybody for having participating. Yes, very interesting, Maxime. We have recorded the presentation. We will send you the link right after if you want to see it again, or if you want to communicate it to your friends or family. Don't hesitate to provide us feedback if there is any things to change, or yeah, just anything to change. And if you like this kind of webinar, we will just let us know, and we will try to do more of them about sustainable development topics. Also, if you're interested in, you can contact me. I will let you my contact in the chat, the contact also of Maxime if you have any further questions. But we can also organize together these kinds of sessions if you want to. Thanks
And
again,
also,
Maxime.
I just want to add that, of course, you can contact me if you have specific questions. Feel free to do it. I'm really open to provide sources or feedbacks if you need.
Guillaume asked the question on the chat.
Yes.
Buying Teslas for Belgian employees won't say the word. Not saving, but if I heard it's better than having normal car, no?
It's better to keep your normal car rather than buying a
Ah,
new electrical one.
Yeah,
If you really want to
Thank
know.
you, Maxime. It's like changing the fridge for a triple A.
yeah, exactly. I fully agree.
Keep the old one, or buy a bicycle instead of a car.
Yeah. And if you have good legs, you can even buy a normal bicycle.
Yeah, if you're not too far, that's true. But that was actually a question I had. Is that but it's maybe for another day. But we hear a lot about the electric car, but I've also heard that for a Tesla, it needs 700,000 kilometers before it's less energy consuming than a regular thermal car. Is that true?
I've heard something about this, but I'm not sure. But there's something definitely that you must watch, and I will share the link just now. Let me just look for it. It's in one of my sources. I've
Yeah, thank you. It's not urgent, but it's just that it's really greenwashing, in my opinion. I mean,
yeah, no, electric cars are a good thing, but of course, what we don't want is for people to rush and to get rid of their car to buy electric cars. So it could be good. And honestly, there is a very good video about it on the Le Réveilleur. I will la voiture électrique, problème de batterie. Yes, okay. I put it here in the chat. This is a really
Thank
nice
you.
video if you want to know about the electric cars, and it takes the whole problem from a really nice perspective, and it's not political. It's really nice video. It will tell you everything you need to know about electric cars.
Great. Thank you, Max. Thank you very much.
Maxime, if I
Yes.
can add something. So I do have a Tesla, and so I've looked around a little bit, and in the end, building a Tesla, it takes so much mining for ore and rare earth that all in all, it's electric cars actually pollutes less than a regular car, but not by a lot. So it is better, it is. But if you do have a normal car, you shouldn't sell it to buy an electric one.
Yeah, I think
Just
that's
need to kill your old one and then buy it.
I think that's I completely agree with this, and it not only works with cars but also with computers and smartphones. It's whenever you buy something new, it's not good, even if it's more efficient or whatever. Especially because of the graph that I showed you regarding the 2 kilos of laptop and 800 of kilos of resources. I let you imagine that for a 2 tons car, it's more than this. And yeah, so you can apply this principle all the time. It's basically it's much better to recycle and to use things until they are really dead rather than buying new. But even though electric cars are the future, I'm not saying. And by the way, there's a really interesting thing that was said by the R&D director of EDF. He said that if at some point the whole population is equipped with electric car, they can use to balance the energy grid, the electricity grid, because they would be plugged to the grid, and there would be some intelligence engine that would use the battery of those cars to store energy when we need to store, and to take energy when we need some energy, if all the cars are plugged to the grid. So this is a serious thing that is taken in the scenarios of full electric scenarios. So yeah, electric cars are something of the future. It's just we don't need to rush and buy electric cars and say that it's green, because it doesn't make sense.
Also, we need to find a way to make better better batteries, because nowadays the way they make it just destroys the landscape. Like really, all they have to mine.
Yeah.
An electric car battery is a disaster. So it's I suppose we have to choose, the lesser evil or something.
Yes, something like this. Something like this. We have some real interesting insight from Nicolas. That one of our consultants did a presentation on hybrid electric cars. So I didn't know about this. It would be nice to write this down. Sorry.
Hello, Maxime. Yes,
Hello,
I have one.
Jean-Lin, I think.
Yes, yeah,
right?
yes, it's me. It's me. Yes, I have a great, let's say, mind, or like, I don't know how to explain that, but one of your problem is not because the energy is more like country based, like everyone is going to do sustainable energy on their country. Like what I think is like, you have solar energy, like you have the sun on one side of the planet and the sun on the other side of the planet. So is there any way, like they talk about worldwide energy sharing or something like that? Because also the wind is going somewhere and the wind is stopped somewhere.
Yeah, this is the question of grids, and grids cannot be on a worldwide scale. It's not. It's an utopia, definitely. But they're working on a grid at the European scale, and it's already a kind of European scale. So the grid is getting better and better, and the wider the grid, the better you can optimize the resource. When there is wind somewhere, and there is not at some other place, you can take the energy here and put it at the other place. But it's amazingly complex to maintain and to maintain such grids, and definitely not on a worldwide scale. But again, I'm not an expert on. It's not my domain. I'm not an expert on electric grids, and I believe we have consultants that work in these fields. So it would be nice to ask them about those questions.
Okay, thank you.
Okay, well, I guess thanks a lot.
Thank you, Max.
Yeah, you're welcome. It was really a pleasure
content.
to share this, and I hope we will do more. I want to do one on also the digital and digital devices. So because it's the positioning of PTC. So yeah, I hope we can do more of those, and I will let Milad try to organize the community out of this.
Thank you, Maxime, again.
Thanks everyone.
Yeah, many thanks.
Yeah, thank you a lot.
Have a nice evening.
Have a good evening.
Yeah.
You too.
Thank
Bye-bye.
you.
Bye.
Thank you. Bye-bye.
Bye. Thank you.